Hello, how are you?
Hey, I'm doing good. How are you?
Good, thanks.
Great, great. Um, so this is actually one of my first times interviewing someone, so I hope you cut me some slack here.
Oh, yeah, no worries, dude. This is my first time doing this too.
Oh, okay, okay, fantastic. So we're both pretty new. I just pulled a question off LeetCode, so I hope you're okay with that. That's what I assumed.
Yeah, sure.
It's okay? Okay, fantastic. What language are you planning to do this in?
So, my main language, the language I like to use in interviews is C++. However, I'm interviewing for an embedded position, so
Mm.
C or C++.
Okay. Okay, you can pick either of those. Up to you then.
Okay.
I actually don't know C++. I did learn C in school though, so it has been a while with the pointers, but hopefully I at least understand what you're trying to get through your explanation. I
Okay.
probably won't be able to correct many of your like syntax or like language specific things. Okay?
Yeah, it's like a pilot's for. This is more just for getting the hang of, like at least from my perspective, it's more for getting the hang of
Just like
going
interviewing,
through out
right?
loud. Yeah, going
Right,
through
right,
a
right.
question.
Definitely, definitely. Okay, cool, cool. As long as we're on the same page. Okay, so this question I'm gonna give you, it's called even odd tree.
Okay.
So have you done that before? Maybe.
Maybe off the top. Not off the top of my head though.
Okay, I'll continue explaining, and if you think you've done it before, we can. I have another question prepared that we can switch to.
Okay.
But for even odd tree, so you have a binary search tree. You're given the root of the tree. And for a binary tree to be an even odd tree, that means at every level of the tree, for example, let's say the root is given, it's level 0, and then let's say it has a left and a right children. Those children will be at level 1, and their children will be at level 2, and their children will be at level 3, and so on.
Okay.
For every even index level, so 0, 2, 4, 6, 8, so on, all the nodes in that level have to be strictly increasing from left to right. So, for example, like we said, if you're given the roots, that's only one value, so that's fine. But let's say you have a bunch of children, and then on the second level, you see like one has a children of 3, one has, and then it goes to like 7 and then 9. That's strictly increasing, so then it's valid. And then the same thing for the odd index levels, sorry. All the levels at that level have to be even and they're strictly decreasing. So I will type out the exact parameters here for you
Okay.
because there's a mouthful there, but hopefully you can understand. And
Every index.
I can draw you an example too if you
Yes,
would
please. Could
like.
you do that?
Yeah. Okay. Okay. So let's say we have this tree. It's one. You can see the drawing pad, right?
Oh, wait. So you're saying at every even index level, so at level 2, there can only be odd numbers, and at
Yeah.
level
It has to
1,
be
there can
odd
only
numbers.
be. Okay.
Yeah. And they have to be strictly increasing or strictly decreasing.
Okay. So off the top of my head, the first thing that's going through my mind is I think it's going to be recursive, and I'm going to be passing the level to each recursion call. So I'm going to be passing whether it's like even or odd or whatever.
Mhm.
And anyway, sorry, keep going.
Okay. Do you see the drawing pad?
If I click drawing mode, yes, I do.
Yes. Okay. Perfect. So as you can see, this is the root. So that's level 0. This is level 1, and then this is level 2, right? So you have like levels in the tree, right?
Yeah.
So you can see on level 1, it's an odd index because it's level 1. And then we have 10, and then we have 4. So 10 and 4 are both even, and 10 is decreasing to 4.
Okay.
And then for level 2, it's 3, 7, 9. They're all odd, and they're all increasing. 3 goes to 7, goes to 9. So
This
then this
isn't a
would
binary
be
tree
a
though.
valid
Or sorry, this
even
isn't.
odd tree.
Okay, so it's not a binary. Wait, sorry. I I got the terms mixed up. Keep going. So when it's odd, they have to be decreasing from left to right, and then when it's even, they have to be increasing from left to right.
Yes, correct.
Got it.
And yeah, so you just have to return true or false if it meets this criteria or not.
Okay. I'm not entirely sure how to compare whether it's increasing or decreasing across recursion calls.
Mhm.
I gotta think about this one for a sec.
Yeah. So yeah, give it some time. Think about how you would do it.
So when you go. This is a hard one.
Yeah, it's a little tricky. Sorry if it's too hard.
No,
You
it's
did
good.
put intermediate, so and this is medium on LeetCode.
Okay.
Tree questions can be very tricky. Yeah.
Yeah. All right, you know what? I'm gonna start going through it a little bit, and I'll think about it as I go. I just typed
Okay.
in this little thing, right?
Yeah, you can type in this. I can you see the top right hand corner? We can
Yeah.
change it to like C. So you have
Oh.
a C like interface, or you can change it to C++.
Yeah, I see that.
So up to you what you want to use.
C++.
Okay.
Then just move this. Okay. So I'm gonna start. It's gonna be a Boolean. Even, odd. Gonna take in. How is this defined? How is the tree structure defined?
How is the tree structure defined? Let me give you the interface for that in C++.
Okay.
So you're given a structure. You're given a tree node pointer to the root.
Okay.
And sorry, I lost track of my window. Give me a second here. So it should look like this.
Okay. Thanks.
Apologies for all the commented out parts. Wait, I can try copying it better. Hold on.
No, it makes sense to me.
Okay, there you go.
Perfect.
And for the you're given a tree node star root. Yep.
Okay, so when you're in the tree node, there's two recursive calls usually. So
Mhm.
you have your base case, and then you do your two recursive calls, and then you do stuff after that. So once you do the two recursive calls, then you actually have the data.
Mhm.
So once I'm at 0, when I do the two recursive calls, I'm going to have 10 and 4.
Mhm.
However, when those ones go in, so when 4 goes in and it gets 7 and 9, 7 and 9 has no idea what 3 is.
Mhm.
I have an hour, right?
Yes.
Okay. Take a sip of coffee, even though it's 11.
I can maybe give you a hint if you would like.
Are you allowed?
I think technically, yeah. But like,
Okay.
okay, let's say if it was a real interview, it'd probably be like, a little mark against you, basically.
Yeah, that's fine.
And
My
I
current
feel like,
job.
I mean, this is just practice, right? So I feel like it's better if I give you a hint and you actually like try than just get fully stuck, right?
Yeah, then just fall on
Okay,
my face.
so there's two suggestions I might have. So you're on this recursive method, right? Do you have to use a recursive method to go through a tree? can you do it iteratively? And that's my first hint. My second hint is if you have it in one recursive call, right, but you don't have it in another recursive call, maybe there's some way for two recursive calls to share information. That's a
Oh.
different hint. So there's almost like two approaches I gave you there.
Yeah. Okay. So I shouldn't have just jumped right into recursion. I think I should have examined it a little more. So I'm gonna look into it iteratively. So the iteration is gonna stop once there is no nodes to go to, or if the condition isn't met. So if there's no more nodes, it's going to return true. If the condition isn't met, it's going to return false. Okay, so it's going to be while something. I'm not sure what the condition is yet. So at every stage, I want to create a list of all nodes to be compared. Wait a second. I could flatten the tree. Okay, let me think for a second on how to flatten a tree. I haven't done that since like third year.
Yeah, it's been a while, hasn't it?
Yeah. Flatten the tree. What restrictions do I have in terms of space and time?
For now, I don't think you have to worry about that.
Okay.
I think as long as you can get a solution, I'm fine with any time. So if you want to like look through the tree n squared times, go ahead.
Okay. What the hell do you flatten? That's why these interviews are hard. If I had this question at work, I'd just Google it.
Yeah. Yeah.
How to flatten.
When you say flatten, what are you trying to get the tree to be basically? Then can I ask? Because I sort of still don't get your thought process, so I'm not sure I can help you anymore.
So when I mean flatten, I mean change it into an array. So in my mind, I'm picturing what this drawing would turn into is it would
How
be.
about you take the example tree that I wrote and like pretend you can do magic and turn it into any array format you want. What would you make that into, and how would that solve your problem?
So I'm just gonna go through
if that's the troubling part, then I can say okay, fine, you can have this array and pretend you have a method for that, and we can like continue with the rest of the problem. Because like that's just thing that's just like something, oh, like there's a function or something that you would have been able to look up, like at work, and I don't want to like penalize you for that, right?
Okay, so in an interview, if this happens and I need a helper function flatten in this case.
Okay, so
I can just type
let's say
flatten.
we have a flatten, right? Yeah.
Okay, so I'm gonna do an array. I'm gonna do an array that is how I would change this into flatten. So it would basically just be, it would be 1, or so it would be 1,
Mhm.
10, 4,
Mhm.
3, 7, 9. And I know you can do that recursively. I cannot remember how. That's what flatten does.
Okay. Okay. So let's pretend we have this already. Can
Yeah.
you write the rest of the methods to check if it's even odd if you're given this array now? So
Yes.
let's say we have like Boolean, even, odd, tree, array, and you're given this, I don't know how C++ does it, is it like that?
Yeah. So C++. I'd
Or
probably
maybe?
use
I don't know.
an object. So I'd go like
Okay,
this.
yeah, you can change it to whatever you want. So could you write that out then?
Yes. The list would be, I guess. However, it would be a 2D list. So I have a for loop now. The for loop starts at 0, which is head.
Mhm.
For loop ends at list size, because lists, to get the size of the sublists, you call list 0 dot size or list 1 dot size. So this would just
Mhm.
be root dot size or length. I believe it's just size. So now I'm checking 1 or 10, 4 or 3, 7, 9. So
Mhm.
the restrictions are, for every even index, if check for even, I'm going to do pseudocode. Check for even index. And then the other case is going to be check for odd. To check for even index, I'm going to do I modulo 2. If I is 1, I modulo 2 is going to be 1. If I is 2, 0, or 4, it's going to be 0.
Mhm.
If I is 2, and now if even index check to check every member of sublist to see if odd. The next one is going to be kind of the same thing.
Mhm. It's the opposite.
Reverse. Odd, even.
Perfect.
And so once this thing goes through, that will return true. However, so if any member, if it is even, I'm going to put this inside the if case. If any number here is even, return false. If any number is even, index have to be strictly increasing. If any number is larger than previous, return false. That's going to be the same thing here, except the opposite, of course.
Mhm.
Odd, and that's decreasing. It's smaller. Let me just finish this if statement here. Actually, I can just make this even shorter. Okay. So now I have my pseudocode for.
That looks right to me. Yeah, are you able to code it then?
Yes, I am. I like to type out all the pseudocode first, as much pseudocode
Okay.
as I can.
Yeah, that's very good. You should be doing that. Yep.
Good to know. So I'm going to have int j in this case, since i's taken equals 0. J will end at root. I think list is either get or at. At or get. Maybe that's just a Java thing.
That
Maybe I can
I
share
don't
that
know.
first.
I'll allow you to like look it up if you need.
Okay, I'm pretty sure you can just do this in C++.
Okay.
My latest project at work's been in C++ also, so that's why this is what I've been doing today.
I see.
So if j is less than root j dot size, no, root I dot size. So this is comparing root I is the current sublist. So right now, if I is 0, it would just be 1. If I is 1, it would be 10.4. Okay, that's so. I'm gonna check for even. So if j modulo 2 index, if it's even, that's going to be true. No, that's going to be false. Even. Turn false. Now I need a way of tracking the previous number and the next number and all that. So I'm going to actually have a starter. What are the restrictions on these numbers? Can they be negatives?
That's a good question. They can be negative.
They can be negative. Okay, so
Yes.
what is the smallest and largest value they can be?
The smallest would be negative 10 to the 6, and the largest would also be 10 to the 6 positive.
10 to the 6. Wait.
Is that greater than C++ size?
No, I'm just trying to figure out what that is, because that's not like 4 or 8. Usually it's an increment of 4 or 8 or something.
It's a million. C++ can handle that, right?
Yeah, so it's a million, right? Okay,
Yeah.
so I'm going to do. So if right now we're checking if any number is larger than previous, so it's either going to have to be negative a million or positive a million. I'm trying to figure out which one it is right now. And even index, all nodes, strictly increaser if any number is. All nodes in low have odd integer values and strictly increasing. Okay, so this statement I had here is wrong. If any number is smaller than the previous, since it's strictly increasing. The number is smaller, so then that one will be larger.
Okay.
Even index. Strictly. Smaller than previous. So I'm going to have int smallest equals the smallest possible number that we could have. So that's negative a million. Off the top of my head, depending on the compiler, I believe this is 16. Can that work? I'd have to double check to see if that can work with an int. I'm not off the top of my head. I'm not sure if the default int. So the default int in C++ is 16 bits. I'm not sure if 16 bits can be 1 million. So I'd have to double check that.
Okay, I mean, I can try to look that up for you right now.
Okay.
Okay, So it says in C/C++, int min is negative this.
Okay, so it's like negative 32,000, right?
It's negative 214748368. Yeah, that looks like it covers a million. So I think you're good on that.
Okay, so I'm good on that one. Okay, so.
And I assume you're let's assume you're good on the max one too. So.
Okay. So right now I'm going to be comparing to I'm going to have the smallest. So if root I j, that is the current element, is increasing, is bigger than smallest. I guess smallest isn't the most accurate way. That's going to be, let's call it previous. If that is bigger than previous, and the first element will, I guess bigger than equal to, because the first element could be negative 1 million. Are they allowed to be bigger than or equal to each other, or do they have to be bigger than? What does increasing mean?
It has to be strictly increasing. So if they're the same, then this would be false, basically.
Okay, so I'm actually going to do negative 1 million and 1 then, because the number can be negative 1 million, in which case this case wouldn't
Glad
work.
you caught that.
Okay. So if that's bigger than previous, we're going to do stuff. Otherwise, turn false. The stuff we're going to do is smallest or previous equals root I j. Okay. Let's go through and double check. So in previous, the smallest possible number that this guy can be is negative 1 million. So if it is negative 1 million, and let's say the next one is also negative 1 million, root I, root j is root. Yes, that works, I believe. So now I'm going to code the next part of it. Int previous equals 1, 1, 2, 3, 1, 2, 1. That's going to be 1,000,001. And for my OCD, I'm going to put that there. Or I could just copy that, but I'm trying to copy paste as least amount as possible. Another dev I used to work with did that. If j is less than root I dot size j plus plus. Now we're going to check, so we're on an odd index. Since we're on an odd index, we have to see if they all nodes will have even. Okay, so I'm going to be doing 2. That guy's true. If that guy's true, then that number is odd and I should return false. Then we do a similar thing to the other one, except we actually reverse the sign. It's less than previous because we're decreasing. Previous equals root I j. Else and false. Okay, I think we're in pretty good shape here.
Okay.
Apart from
yeah,
this
looks
flatten.
good to me. Can you run through this code with the example tree I gave you?
Yes, I'm going to do that out loud. So
Yes.
we start off for int equals 0. I'm actually going to, I can just track this. Okay, so int equals 0, all that stuff. If I is equal to 0, if I modulo 2 returns false, that means I modulo 2 is 0. Okay, you know what? This actually isn't the most readable, to me at least. So I'm going to change it back.
Okay. Shouldn't line
No,
60
I
be
did,
0? And
yeah,
then the other one be 1? Okay.
yeah.
If even, it is modulo 2 equals 0. No
Both
remaining
multiple,
left.
right?
Okay.
So I modulo 2 is 0, which it is 0. So now I have this int previous. I'm actually going to keep track of this previous guy up here. Equals currently, it's negative. Now we're actually in this guy. Now we're in here. J is, if J modulo 2 returns, if J modulo 2 is 0, J is 0. Wait a second. That's not right.
Good job. You caught it. Yeah. Yeah. This is why I ask people to run through their code.
Yeah.
Okay, if it's not, then return false.
Actually,
I think
well,
you
my
should
mind
fix
is on
it
this
on
though. I'm gonna
line
fix it.
87 as well. Yeah. IJ, okay. Return false if previous. Okay.
All right. So that will keep going.
Okay.
1 is, that returns 1. So this guy passes. So now on to the next one. Is 1 bigger than that? Yes, it is. Now previous is set to 1. So we are actually at the root I size. So now we increment. Well, we exit this guy. We exit this. Sorry, you can't see my cursor. We exit this loop. We go to here. This doesn't apply. That doesn't get triggered. So then we go, and it's probably a good idea to actually, I'm going to keep track of all these. Now I is equal to 1.
Correct.
1 modulo 2 is 1. So this guy doesn't get executed. Now we're on to this guy. Previous is now 1, 0, 0, 0, 0, 0, 1. So J 0, and keep track of root. Root I. Oh.
Sorry, I was typing stuff.
Root I J is 10. So is 10 modulo 2 returns 0. We're good there. Is it less than previous? It is. So now previous is 10. Increment J. J is 1. Root ij is 4. 4 modulo 2 returns 0, so we're good there. 4 is less than previous, so we're good there. Previous is now equal to 4. So root J is now root size, should probably keep track of root size up here too. J is equal to root size, we exit there. We go to the next one. So now we increment I again. I is 2, J doesn't exist anymore. So now we're on to here. We're on to this guy, because 2 modulo 2 is 0. So previous is set to negative 1,000,001. J is created. And root ij is 3. Is 3 modulo 2 returns 1. So we're good for this check. 3 is bigger than negative 1,000,001. Previous equals 3. Increment j. Root ij is now 7. 7 modulo 2 is 1. So we're good there. 7 is bigger than 3. Now we change that one to 7. We increment j. J is equal to 2. This guy is equal to 9. So now 9 modulo 2 is 1. It is bigger than 7. So previous is 9. And now j is equal to root I dot size. I is incremented. I is now equal to root dot size. So we actually return true. This is a valid tree. So
okay.
now I would go and I would test an invalid tree. So let's create an invalid one. Let's say first one's still good. Let's say this number is negative 1,000,002. Everything else is okay. It's just that one thing. And one, I don't know. These guys have to be
159 maybe.
Yeah, it doesn't. I'm over. Yeah, this doesn't matter.
I think the negative 1,000,002 would actually make your code get messed up. But I think as we defined earlier, you wouldn't get a number like that. So maybe just try putting in like an odd number.
Sorry, yeah, no,
Yeah.
it's never going to be that. It's never ever going to be
Yeah.
that. So I'm gonna actually try negative 11 instead.
Yeah, just try negative 11 and yeah.
Because that was the bounds. That was the requirement.
Yeah,
that I based it off of. Okay, so we're gonna try this one, and this should return false.
Yeah.
So let's wipe all of these guys. No J, no previous, no root, anything. Okay, so we start it. Root, so I equals 0. Okay. So I modulo 2 is I modulo 2 equals 0. So we go into this first one. Can you see it when I highlight stuff, by the way?
Yeah, I can see you highlight.
Okay. Probably
I just can't see your mouse pointer.
Okay, so now we have previous. Let's put previous up here. Previous equals negative 1,000,001, and J is created. So we have J equals 0. Root I, J, I don't know, I wrote 4. Equals 3. 3 modulo 2 equals
1.
Sorry, equals 1. So yeah, obviously that one's okay. Previous is now going to be 3. And we are at J gets incremented. Now we are at that size. This next block doesn't get called because this condition. So I is incremented. Oh yeah, J is no longer. I is incremented. Previous is no longer, but it's about to be. So now we're on this guy that should fail it, -11. So now I modulo 2, -11 modulo 2. Would that equal 1 or -1?
I think it should be. That's a good question actually. I'm not sure about C++, but I think in Java it should just be 1.
Okay.
Can you maybe just Google it, or I can Google it for you. C++ negative modulo.
Okay, you know what? I don't actually know. However, I know how to accommodate for both cases. So if it does return -1, I would actually change my code accordingly. I would call the abs function. So I would compare the abs value. So it would actually just compare 11.
Okay. That's perfect. Yeah, that definitely solves the issue on that.
I'm going to put that in here as well. Okay, so we're good there. I'm not going to put abs here because we're comparing this guy. So previous currently is
1,000,001, and -11 is less than that.
Yes. Then -11 is less than that, so we're actually good there. -11. So now we increment. J is now 1. Root ij is 4. Wait a second.
Well, no, it actually would have been false on the -11, right?
Yeah, it's about it. Yeah. My bad there.
Okay. All good.
Getting ahead of myself.
Okay.
So yeah, -11 would actually. I think we can safely say it's good.
It's working. Yeah, I agree. I think you did everything right. We can pretty much stop here. I would say, do you think maybe you can think of a way in, like, I don't know, we only have 15 minutes left ish, so like the bulk of the problem here, well, like, you sort of did half of it, which is the checking is layer part. Do you think you could think of anything for the, like, you flattening the tree into this array format? Do you think you could do that? If you can't, it's fine. Like, maybe just talk about it. You don't have to code it up, or just like write pseudocode even, maybe.
Okay, so I know what I'm gonna do after the step. So the first step inside the function call is going to be if there is no left, or sorry, if the current node that's passed in is null. I'm actually gonna just put that in. So if
you can, like, you wrote down some very good comments in your other code. So, like, if maybe just do something like that, and I can get a general idea.
Fruit is null, return. You might have to return something. However, I know that this is the base case. This is the case where it ends at. So then the next cases would call root left. The next thing would be a function call to root right. And then after that, you would actually add to an array. And part of this is actually going to be passing in an array. So for the very first call, I would actually be bool even odd tree node. And that guy would actually return the value, because this is based on the leak code. Usually they give you the thing that the test cases are matched against, and this is the the word I'm looking for? Whatever. This is the correct one with just one tree node argument. So now I'm going to
Mhm.
call let's call this recursive turn even odd tree recursive root and new list int int. So this guy,
And that guy would return a list, I assume, or
yeah. So with new, if
okay.
we a pointer or something, I can't think what that right now. Let's just try to get
So
the
like something like this, right? Okay. I get it. Okay. Okay, cool. We can stop here, I guess. I think overall, pretty good job.
Okay.
Although we did sort of split the problem into two. So if this was like a real interview, like technically you got like half, maybe 3/4 of the question. Like the tree recursion part, that is a big testing part of the problem. Like, are you able to recursively go through the tree, right? So I think that's something you should just it's pretty much you got to memorize it. It's like I don't know. Did you go to university
Yes.
for
Yes.
computer science? Okay, like I'm sure you learned like BFS or like DFS, right?
Yeah,
And there's
so I
like
did. So I did my degree. I graduated in 2019, and then I've been working
oh
since then. So I haven't done recursive trees, and I've done a little bit of it
right
in
right
LeetCode
yeah
this past
it's been
week,
a
but
while. I feel you yeah. And like usually at work like usually no one uses trees and whatever, but like unfortunately I think in a lot of these interviews people will give tree problems because it really like tests your like skills with like basic stuff. Like I know, sure, like people usually don't use trees, but I think recursive functions are important thing that people should know, right?
yeah.
Yeah. So it's that's just the main part. Like you gotta restudy those algorithms for like BFS or DFS. Um, and yeah, that's pretty much it. Some other feedback, I guess. So I know you asked me while you were coding, oh, can the numbers be negative? Oh, what is the maximum, right? I
Yes.
think you should really do that at the beginning, right? Because like
Yeah.
I personally think like if you're just like jumping in and then you realize this in the middle, that this time it was easy, right? You can stick an absolute value on your if statement, and that can solve it. You can like change your
It's not
million
always
to
that
a million
easy.
and one, and it's fine. But if it's some other constraint that is like more complicated, it might change your entire code, and like
Yeah.
what you wrote might not even be valid. So you really gotta clarify those constraints early before you jump into it. Okay.
Okay.
Um, and last thing, I think you mentioned in the middle you were saying like something about like copy pasting, it's like the same but like it's just like inverse, like one is for even, this is for the odd case, so then we just like switch around the comparison signs. I think it I don't think you have to technically do it, but in my opinion it's very it shows you're very like versatile and you're like a good coder if you make like a helper function and you like wrap both things. So like for example, if you had like a check even or odd function, right? And you wrapped line 65 to 79, right? And then you pass in a little flag that's like true or false, and then you just use this same code basically. But then in one case it would go into like one of these, in the other case it goes another way. That way
Oh
you're
yeah.
you're technically writing less code, right? So yeah, so like
More readable.
something
Yeah.
it's like more readable, and like you said, like if I like you yourself said like I don't like when people copy paste at work, right? So like
Yeah.
clearly there's some shared functions in here that you can like essentially reuse. Like at least the for loop, like
Yeah.
line 70, like that's shared between both of them. Both of them are for looping through the list or whatever, right? So always try to think of like how like try to reduce the amount of code you're writing essentially.
Yeah. Okay.
And yeah, otherwise, I think you had a good grasp on the modular part, so that was good. Good logic on the figuring out what is previous and updating that, and being able to check larger, smaller. Um, and yeah, besides that, overall good. I think the only real big lacking thing is the tree making it into the array part. All right.
Yeah. Yeah.
Yeah.
Okay. So my question about that question is,
Mhm.
so that is just knowledge I didn't have, or knowledge I have not exercised
In a
in a
while,
while.
right? Yeah.
So how
Yeah.
can I be so that's the biggest fault of this whole interview. So that's what I have to
Mhm.
work on.
Yeah.
However, how I'm not like the question on the interview could not be recursion. How can I make sure that no matter what that question is, uh, like, do I just keep doing leak code challenges?
I mean, yeah, practice makes perfect, but wait, what do you mean it couldn't been recursive?
So let's say after this interview,
Mhm.
I go and I master recursion, and then
Mhm.
I get into the next interview, and they ask me a question about a different concept,
Mhm.
uh, that I come across the same issue I came across in this interview. How can I
Mhm.
be sure to cover all of those bases?
I mean, I think that you just gotta practice a lot of
I just got to
things,
practice.
a lot
Okay,
of
I just got to
problems.
keep
Yeah,
doing these
which is
leak code
which is
problems.
the well, yeah, that's honestly the tricky part. When you say it can't be recursive, I I don't know if you learned it in school, but if you do like BFS or DFS, you can do both of those either
Iteratively.
iteratively or recursively. So like when you said, "Oh shoot, it isn't recursive," technically you can. It's just a little bit harder to write out.
Yeah, so what I meant when I
So
said that is,
yeah.
I know
Mhm.
you have to examine all possible solutions. So I hadn't
Mhm.
examined that possibility. I just went gung ho on the recursion, and I should have
Yeah,
stopped.
yeah. That is one oh yeah, I forgot to mention that. Yeah, just don't like, be gun ho. Like if you explain your process, like the interviewer might be able to help you guide. Like, oh, you're on the right track. Have you thought of doing it a different way? Like, they can give you like pseudo hints, right? But if you just
Hmm.
charge in and start coding, then the interviewer just like, oh, I guess he knows his stuff then, and just starts critiquing you, like, yeah,
Yeah, yeah, okay.
yeah. All right, cool then. I guess we got 5 more minutes. Do you have any other questions or anything you want to ask me? Otherwise, I think we're done
Um,
here.
what do you? What's your situation like? So I have what almost 2 years of work and then school before that.
Oh, okay. I'm probably a bit older than you. I graduated from college in 2017, so I
Okay,
have 4 years of experience in the industry. Yeah.
okay, cool. Are you
Yeah.
currently
And
hiring right now?
am I currently hiring?
Like, I'm wondering what the
What the what?
let me think about
Oh, is my company hiring? Oh,
no, 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 no,
I
no,
don't
no, no,
think
no,
my
no, no.
team or company is. Sorry. I
No, no,
I
no. I'm
am
wondering.
thinking of changing jobs maybe, so that's why I was practicing on here.
That's what I was trying to ask. Yeah,
I
that's what
see,
I
I
was
see.
asking. If
Yeah,
yeah,
yeah, yeah. I think I might change jobs, so I was like, oh, I gotta practice. So I've been doing a lot of lead code, and then I just signed up for this interviewing.io thing. So
is there anything else
yeah.
that you're doing? Anything I should be
um,
looking at?
besides lead code and this, have you read the book Cracking the Coding Interview?
Cracking the coding interview. I have not.
Yeah, I can send you like I think you can Google like a PDF. It's called this Cracking the Coding Interview.
Okay, I could probably
It's
torrent a
it's like
PDF.
it's a book written by this person who was like at Google, right? And she did a lot of interviewing of other people. So the book is really big. So it covers like basically all the concepts that you need to know. And like I know you'll probably look at it and be like, "Oh my god, there's so much stuff to learn." But like if you can do everything in there, like these interviews will be like a breeze basically. So
Okay. Yeah,
yeah.
because that was my next question. Is I'm finding a difficulties finding practice questions relevant to my what I'm interviewing for. I'm interviewing for an embedded software position, and all of these are just
Mm,
kind of general. And they told me that
yeah.
it would be heavy on like RTOS stuff, interrupts,
Right.
and all that.
I see. I see. Yeah,
So I'm
I
gonna
feel
have a
like
look at this book.
interviewing.io is more general type of question. So I'm not sure um it can help you as much with like embedded systems and stuff. Like there might be like a few questions in the book.
That's what
Like
I'm
I think
thinking.
there might be like half a chapter in there on that, but I'm yeah, I don't know.
Okay. Yeah, I'll have a look at the book.
Yeah.
Thanks.
Yeah. Okay, cool. Good luck then. Yeah.
Thanks, man.
All right.
Yeah.
Goodbye. See ya. Yep.